I am on a quest. I want to find out how to make software and hardware perform at their peak. I want to know how to make applications faster and more efficient. And while I'm at it, I want to have a little fun. Don't think I can do it? Just watch me. I'm Scott Moore, and this is the Performance Tour. Hey, didn't we just do this? I know, I can't believe it's already time for another episode of the Performance Tour as well. We're now getting into summertime, my favorite time, but I have been busy during the spring. We went up to Atlanta, Georgia and had a live Performance Tour event there. Traveled across to Austin, Texas for another live event, stopping in Houston, Texas for a private client event, and then making our way back through the bayous of Louisiana and the southern U.S., and just having fun in the Gulf states. So now we're back, and I did a ton of interviews that I'm going to be sharing over the next few episodes of the series this year. But you know, I want to take you back to Nashville for today's subject, and it's about security. Sometimes you just get an interview you weren't even expecting. It turns out to be a great conversation, such as the case today. I've had many conversations over the past several months with colleagues saying, you know, Scott, security and performance, those disciplines share a lot of things technology-wise, technique-wise, process-wise. Those same techniques are used for different purposes, but you can move from one discipline into another fairly smooth. And I've had ex-employees that have actually done that have moved from the performance load testing space into the security testing space quite successfully. And they have all told me we used our skill sets that we learned from load testing to transition easily into security testing. Of course, this is a different mindset, and I understand that. And I got to thinking about that, and I thought I should talk to somebody who's in that security space, in the security testing space, the trying to get security into a DevOps pipeline. And that's where I met Dennis Hurst of Saltworks Security, and I think you'll enjoy this as much as I did. Thanks for being on the show.
Good to see you again.
We're really going to focus on the parallels of security and performance and how they relate to each other, how they got a lot of things in common, and Dennis has a great perspective on some of this stuff. So thanks for being with me today.
Yeah, thanks for having me. I appreciate it.
So tell me a little bit about you, your company, and what you do.
Yeah, so Dennis Hurst. I've been a developer all of my life. My running joke was when I was in high school, I made more money coding than flipping burgers. So kind of been a developer since I had hair. And then got into security about 22 years ago. I helped write a program called Web Inspect, which is a dynamic scanner for websites for security checking. And I've been in application security specifically since then. Okay. So started a company, Saltworks Security, about 10 years ago. And we were an application security consulting company. We help people basically integrate security into their dev processes. So the whole shift left movement is really where we live and breathe.
If I'm doing a load test, first thing I'm going to do is automate a script that's going to do a process like this. It's going to log in, click here, do this, and I'm going to capture that recording. Right. I'm putting a sniffer on the network, and I'm recording this traffic and then converting that into code that then I can play back, and it sends this request to a web server, probably if I'm doing the web protocol, and then I'm trying to see what it's going to give me back. Is it going to let me in? Is it going to be an error? I'm not looking for security, but I'm trying to get. So it's the same thing with security scanning, right? You're loading up a proxy. You're analyzing traffic that's happening. You're just going to do different stuff with the results. Right?
Yeah, it's very similar in that we're doing the same thing, like you're saying. We have to make the tool, especially for dynamic scanning, we have to make the tool log in, stay logged in, because we're going to do all kinds of goofy stuff that's going to kick us out. Right. Hopefully, it should. So then we have to log ourselves back in, and the tool, we have to tell the tool how to do that. But if you think about performance testing, you're going to take a series of actions, and then you're going to take that series of actions over and over and over again at ever-growing speed and from multiple threads. With security, what we're really going to do is take those requests and start to modify bits and pieces of them. So if there's parameters coming in, we're going to take one parameter and start to manipulate it and leave everything else alone. But we're going to do it thousands and thousands and thousands of times. So it's very, very similar. The difference being you're trying to break the application by loading it and seeing how it handles it. We're trying to, in a very technically similar act, we're simply trying to break the application by sending it things it didn't expect and then see what happens at those limits.
Right.
But it's the same really concept of everything breaks at a limit. Mm-hmm. So what's the limit of that? And performance is how much load can I hit it with and crash it or break it or do something it wasn't intended to do. Right. Security is, what if I send in data that they didn't expect, malicious data, does it break? And that would be another type of extreme of, you expected an integer and I send you a huge number or a string. So it's that unexpected input. So, and that kind of gets into, what we were chatting about before of, that starts to sound a whole lot like functional testing.
Right.
Of you go to a site, you click a button the developer didn't expect and it does something goofy. It's kind of what we're doing. We're sending in malicious things the developer didn't expect to see, is there a bad outcome? And that could be a performance related issue where we buffer overflow it like you would in performance, or it can look a whole lot more like functional testing where we're just sending in weird stuff.
Yeah.
And really pen testing as it's kind of taking that dynamic scanning and going to that next level of pen testing where you have these highly skilled ethical hackers, however you want to say that. What they're really doing is using their intelligence to figure out what did the developer probably not expect? What can I do that they didn't think about? Or what was that developer expecting so I can do something unexpected and to optimize that? But
Sure.
Very related to quality in my opinion. It's funny going back 20 years with Weapons Backed and Spy Dynamics, we always felt like we really belonged in that quality area of does it function, does it perform, and is it secure? Mm-hmm. We always felt like those were highly tied together and complementary. And we're seeing that more with DevOps now.
And every time I hear this conversation, of course it trips a hot wire in me because we, as security, performance engineers, we get relegated to the non-functional requirements category.
Right.
Like, what other thing do we name something for what it's not? Yes,
Right.
we're not functional, but we are something. And of course,
Right.
I understand what they're saying. It's a term in the industry, but it's a hot button because I would consider those operational requirements and everything.
Yeah.
Because, it might function under a single user under this particular test case that you're looking for, but
Right.
the unexpected or the underload, it can't operate in production without meeting these other requirements.
Right.
So is it functional if it doesn't perform at all under 500 virtual users when you can't reach it and
Yeah.
you're getting 503s? Or does it really function if you've suddenly done something to hack the web server and it no longer responds to requests?
Right. I have to, if I use my bank software and I can't log into my bank because 100 other people are trying it at the same time, well, I don't try, then it's useless. It's not that a functional requirement was our customers should be able to use this thing,
Right.
which relates to performance. And then if it's not secure, I don't trust it. Well, if it's not trusted, it's useless to me as well. So, yeah, I agree with you on that. The non-functional requirement, it's almost an assumed.
Right.
It's like, if you were designing a car, we see cars going by, and if you're designing a car and I said, oh, you want it to ride on the road? Mm-hmm. Well, okay, I didn't put it in the specs, but yes, it should be able to drive down the road.
Right. Exactly.
So yeah, it's almost obvious of it should be secure and it should perform because we designed it for use.
Right.
So it's almost an obvious requirement.
What is the lowest hanging fruit that you see with your company when you go into companies and you're like, it's 2023, they should be getting this by now, but nope, they don't have this, they don't have that, and you wish that they did have that covered,
Right.
so you could get into the deeper level stuff. What's the most common things that are wrong in security?
Some of the things are just such basic blocking and tackling, and there's I could talk about particular vulnerabilities like cross-site scripting still pops up and SQL injection, and there's the ones we all know about. Some of the most basic fundamental things is having a good design architecture. So I go into companies and I'll say, well, explain how this application works. Open-ended question, tell me what it is. And they won't have any kind of good design documentation, which probably means they didn't really design it very well. So it's that fundamental thing of, how did you design this to work? Mm-hmm. And so many applications seems like they evolve we had this piece and that piece, and we kind of duct tape it all together. It's very tribal, and it's building, and then they like it, and it grows. Well, the problem with that is you don't understand truly how it works. So little things like you don't know where confidential data is. Where you're taking credit cards number, where do they get stored? Just basic questions. You're taking healthcare data. You're taking whatever your confidential data is. Where do they get stored? What's its life cycle through the system? How is it designed for performance? And when it reaches the end of its capabilities, how does it fail? What's the default fail? It's kind of electrical engineering. It's do you fail open or do you fail closed? Failing open would be you break the circuit and the house doesn't burn down. Failing closed is the house burns down. We should fail open. Security has the same problem.
You see a lot of burning houses.
Yeah, there's a lot of burning houses. In security, yes. So, but you see just fundamental, and we do a thing called threat modeling, which is sort of it's a very simplistic approach to getting an architecture. What does this thing do? How is it built? What systems run? Where does data flow? So it's similar to data flow diagrams. It's kind of a first cousin of your typical architecture things, but it's just understanding how's this built? And it's amazing to me how many vulnerabilities we find just fundamentally in architecture, where something is exposed that wasn't designed to be exposed. We found, for example, web services that were designed for back-end processing that were actually exposed externally. Actually, the reason I'm in this industry, kind of an anecdote, but say how long this has been going on. I actually got into application security. These guys had founded the company Spy Dynamics. We eventually wrote WebInspect. And I was working at a bank. I was an architect. And we had architected a system, and we had a front-end loan application system and a back-end processing system. And they were two separate things. One was external for users. One was purely internal, which we thought, for customer service reps to process. So we wrote it, and that was fine. But when we deployed it, we didn't give good deployment instructions. So the people that deployed it simply put all of it on every server. And you could actually get to the entire back-end application processing through the internet. It was kind of hidden, but they found it and exploited it. And so that's how I got to know these guys. And I left there and joined Spy, and we wrote WebInspect. But it was but that kind of fundamental mistake of I didn't create an architectural diagram that I could go to the guy that installed it and say, hey, this is internal. Don't put that on the internet, by the way. But that's the kind of thing you can find through pen testing and dynamic scanning because it's the real world. But if nobody knows it's there, sometimes it's hard to find. But if you find it, it's a gold mine of exploitation.
Okay, so here's where my thought process is going. Is this because companies aren't investing in really good architects to begin with to design a system, and they're relying more on developers? And is that a result of putting more responsibilities on the developers and the DevOps culture to say, you're responsible for it, you build it, you take care of it, and maybe those developers aren't thinking of security or performance when they're designing?
I think it's more a case of we have good architects, but typically the architects have a thing they govern. For example, you'll have data architects, you'll have network architects, and they're really looking at what are the rules of the road if you wish to play in our systems. So if I want to take a web application and run it, there's an architectural group that says, how do we use the network? How do we use the proxy? How do we use all the componentry of it? And so when I go through an architectural review, what I'm really telling them is, did I build my app according to your architectural standards? And they're saying, yes, you did. They're not really asking the question, was it a really dumb idea to do that? Because they assume that the developers know it. And the developers, like in my case, I knew as the developer that there was a public side and a private side. The breakdown occurred in communication. So it wasn't that anybody was bad in that case. I mean, I was one of the architects that choked, basically. It was a case of not properly documenting in a very clear, concise way, what does the system do? What are the expectations of this thing? These pieces are internal. Those pieces are external. These are internal. Here are the control mechanisms. And doing it in a very clear way that database people and network people and developers and all the different architects understand. And then you take all that to the cloud, and it gets worse because it's no longer boxes and wires. It's just configuration. Right. So if nobody knows what it's supposed to do, everybody, it's kind of the old adage of, 3 blind people come up to an elephant and one feels a snake and one feels a tree trunk. And it's kind of like that, of there's not a good communication of what is the whole thing.
So I don't expect the developer to test at the same level that I test at. I'm going to do a much higher level when I do an integrated test right before it goes to production. But as we shift this left, I want them to be able to test their feature or functionality, whether that's in a pipeline or whatever it is, how they get that done. I would think it would be the same thing for you. In my case, they may pull down an open source tool. They might use something like Neoload early in the cycle to catch as much as they can. So it makes our job a little easier. What are you doing at Saltworks to provide a shift left opportunity for testing security that way?
Very similar, honestly. There are different, obviously slightly different tools that we use for security testing, but they're very similar. So very early on in the coding process, they can do things like source code analysis to look and see, did they make a mistake? They can use open source scanners to look and see, did they use a library? Like Log4j was the big one a few years ago. Did they download a Log4j they shouldn't have and integrate it with their tools? The idea there, very similar to what you're talking about, is find it very early, fix it very early, and let's not have to deal with those problems down the pipeline. As we move kind of down the food chain and through the pipeline, they can do things like dynamic scanning in test, just like you would have a performance, potentially like a functional testing script. We could do dynamic testing kind of around the same time to look for that low-lying fruit. And then once it goes into staging, that's where we would start talking about things like penetration test, which would be an analogy to a heavy performance test. It's heavily involved, highly skilled, really, really exercising the system, but it's also quite expensive.
Right.
So you don't do it every time, but the idea being as long as we do it periodically, not too much should creep in bad.
Right.
Similar to performance testing.
If you do it good over here, you don't need as much over here.
Right.
This sort of becomes a checkbox in a way, but in a good way,
Right.
because you're doing continuously over here.
Yeah, and my running joke was if you have a pen tester find something that a dynamic scanner can find, you just wasted money because you paid a person to do what a machine can do.
Right.
Likewise, if you find something that your static analysis tool or your open source analysis tool should have found, but a pen tester finds it, well, you just wasted time and money.
Right.
Because you could have done it far more cheaply and used those resources of your pen tester far more cost effectively. They're scarce resources. They're expensive, they're rare to find good ones, so you really want to use them well. Similar to performance testing. It's hard to find a good performance engineer that's really good. It's an art.
Yes, that's true.
It's an art. But it is, it's an art and a science. You have to have a huge body of knowledge about how systems work. And then there's just an intuitive thing. But it's an art and a science, and it's rare to find that. So you want to use those resources well, use them, but use them well. So yeah, you should always shift left as much as you can for a lot of the same reasons. It's cheaper to fix it, less painful to the developer. As I've been a developer my whole life, if you find something 5 minutes after I mess it up, I can fix that really quick. Right. If you come to me a year later, I'm going to spend 2 days figuring out what I did.
Yeah.
Even if I document it, I'll be thinking, who did that?
Yeah.
So it's just so much easier. And it's kinder to the developer. As a developer, it always drove me crazy. I need to know if I can go live or not. And there's a lot of questions that have to get asked. And security has this nasty habit of sitting at the end of that life cycle going, well, you go build it, and then we'll tell you if you can go live or not. Well, it's really nice if you tell them earlier. Mm-hmm. So having security to the extent possible, as early as possible, is huge, because it does help the business and the developers and everybody know, yes, we are on track to go live, or no, we have a problem we need to address. Exactly the same logic as quality. You want to do as much as you can, as early as you can. It's cheaper, it makes the whole thing more predictable to the business, which is really what we're kind of here to do. Right. Is deliver systems that function well, perform well, are secure, and serve our customers. So that helps us to do that well.
Fantastic conversation. Enjoyed meeting Dennis, and out of that, we really became friends. And Saltworks Security is playing a closer role with what I'm doing with my content. So that turned out to be great. Now, we did stop at a barbecue place while I was up there called Shotgun Willie's, which was a Texas-based barbecue place based in Tennessee. Check it out. hope you enjoyed this episode of the Performance Tour, and I hope you'll get a chance to see us at some of our live events as we go into summer and fall this year. But if not, keep watching the Performance Tour for great content that we're going to be bringing the rest of this year, and I'll see you on the road. Crazy, but that's how it goes. Millions of websites going down slow. Maybe it's not too late to learn how to test so people don't wait. Woo! That was just all wrong. That was all of it. It was just all wrong.